My name is Scott Duchin. I'm going to be talking about the project at Motorola that we use Gradle for. So I actually work at Google, and I was sent over to Motorola to help Googleize Motorola. And after being there for like a month or two, I decided that they need a complete revisit on their entire development platform, pretty much. They had like 3,700 repos running around, and you couldn't find source code, and everybody's in their own little silo. And at Google, everything's totally different. There's like one single source repository. And I'm trying to get them to build for maintenance, and they don't write their test code. They have QA do their testing for them, and the code's not well documented. So, so I decided to take on the task to build the entire Google infrastructure for Motorola. Obviously, it's only me versus a team of 300 people at Google, so I had to look around for some tools, and I picked Gradle for that. So the overall structure is something like Motorola 1 on top, and then we have a Java directory and a Java test directory. They mirror each other. And as you can, so we just go right down, and then all the projects are, all the build files are inside the tree. So they're all in the leaves. And we have test suites and stuff on the test side, and war file and jar files and builds and stuff on the other side. So that was the task. So it's like completely upside down Gradle for most projects. And it was a little more difficult than I had hoped in the beginning, but it did work out. I got pretty close on my own, and then I brought in Ben, who's a Gradle consultant, and he helped polish it all off nicely. So what the build files actually look like, if you want to have a jar where you just say Java jar, and you drop in the name of the jar you want and how you want to build it. If you're building your actually compile step is the middle one, which says Java build on it, and there you would actually list all the Java files, and you would put your other files that the other packages that you're dependent on. So you would point to those dependencies. And then you have libs that I define in a libs.gradle, which defines the current version for everything. So I'm also trying to lock down a single version for development. If you want to build a war, it looks just like the jar. And if you build a test suite, you just start adding other packages you want to build with yours. So you can pinpoint and speed up your build process by only building your own tests that you're interested in. So if you're working in this service, you just build a test suite for your service. It will go through the entire tree and pull in all the dependencies for you. So the overall project is that we have two Git repositories. I had one for the Storm Central, I call it, where we actually download, and we have we keep all the jars there. And that has both Google releases, third-party releases, and some tools such as Gradle and Groovy and stuff are loaded there. And then we have the Motorola 1, which has all the Java tree and the Java test tree and the JavaScript T and resources and other things like that. And it also has the Gradle and the Groovy scripts inside there. Those could possibly be moved elsewhere. But the base for the Gradle, the base for the Gradle build is inside Motorola One. And we also use Gerrit for code reviews and Jenkins for testing, and we use Gradle for the builds. So with these open tools, I was able to mimic, and it won't be as fast as the stuff they do at at Google, because they do awesome work over there. But overall, I was able to mimic the development practices of Google and Motorola with Gradle. So inside the Motorola One directory, we have a bin directory where I have some scripts, and I also have a bash RC file there. So I only have them point to my bash RC file here in their bash RC file, and sets up the entire environment for them. It sets up all kinds of directory pointers and scripts and etc. The build for the Gradle goes in the build directory. That's a temporary workspace. It's not part of the source. Build.gradle, of course, is the main one. It actually uses this thing called config slurper. So what we do is we search for all the build files, and config slurper takes these things like the Java build file. I'm sorry, didn't mean to do that. It actually takes these groupings, and it hands you the groupings, and you can keep on using it more and more and more, deeper and deeper. So you get these config objects back from it, and that's the way it was actually built. So I actually have a Gradle. So what I do is I build up these config objects using the config slurper, and those are actually, these config objects are then passed to the corresponding Gradle package, which has the same name, .gradle, in the Gradle directory, and it does the work. So if I jump ahead here, the Gradle package, you'll see a Java build, a Java test suite, a Java war, Java jar. So all those config objects are then passed to the corresponding Gradle object that then does that one task. That's how I got it all configured.
So a new configuration that someone might create has to then be involved or be consumable by a corresponding Gradle file?
Yeah, I mean, for now, yeah. I mean, I had to handcraft these build files and jar files. Since I'm upside down, I don't get all the support I would wish to from the current Gradle package. So you have to do a lot of the stuff manually. But I don't mind doing a little bit. I don't mind doing one day's worth of work, so everybody in the company can get like jar files and war files and stuff like that. It's not that hard. The main one, which is a Java build one, actually builds up a lot of information the other ones can use. So it's not quite that bad.
So just to be clear, so you're basically creating a hierarchy of configurations that then get fed in.
No, there's only a handful of these build rows. I got most of them here. Oh, I'm sorry. So, can you see?
So yeah, I'm just trying to establish. So each of your different projects in the leaves.
They all look alike. All the projects in the leaves are just build files, and
They're reusing these.
They all generate their own war file for deployment to GAE or something like that, or they create a jar file for sharing for something else. So all the projects can have their own war files and jar files and whatever else, which usually, if you build a normal Gradle project, you ask for a war, you get one for the whole tree. So I don't want one for the whole tree, I want one for a branch. So we just drop these build files where you want the WAR files or where you want a jar file. Now, the build files are in every single package because you need to compile. So there's always a compile rules. And each build file will point to its dependencies, and you can't have cyclic dependencies and stuff like that still. But they each point to what they're using. And when you're building a WAR file up, it actually goes through those dependencies and pulls in all the classes for the current one you're at, and then it follows through the dependencies, bringing those classes, and keeps on going down until
So
those.
it's sort of a hierarchy of build files.
Yeah, yeah. So if you have a test suite, your test suite would only compile those things that you're working on in your own project. It won't compile the whole system. So you don't have to worry about how big this thing gets, because you're only focusing on what you're actually using.
Remember the Gradle project, how many projects you have? One Gradle project?
We have. I actually have two projects now. There's a Java project, and the Groovy is its own little project by itself. And the Groovy is just a bunch of support for the Gradle right now. Sorry. No, he was pointing at me to repeat the question. So, I'm sorry, I'm really bad at it. So your question was, how many projects are actually in this? So currently we have two projects. One project is for Java, the other project is for Groovy. We probably make a third project when we get a little further advanced for JavaScript. But I mean, since they are all independent, but they're going to be the same kind of behavior and stuff probably. I don't want to talk about what's not there yet. You had a question?
It's not important.
Okay. So so we have like a config directory which holds the check style rules, and we have a Gradle directory which has all these individual Gradle scripts, and we have a Groovy library that it's very small at the moment, and it might not even be necessary if I could read the current Groovy libraries. I mean, it's hard finding everything, so I built some things up. And we have the Java test resources, and we also have a resources test now, and then we have the settings at Gradle. So the settings at Gradle is very, very small. It's got the two projects in it. So we have all these Gradle scripts to build everything. I also have a utility.gradle that's shared between these things for a lot of shared methods and et cetera. Then we have the Groovy, which has a few things for testing, for pre-submits, some I/O, some lang, not much. And the other thing that we do very differently is that we have our own repository. So I'm not going out to Storm to Maven Central because I don't want people to have 15 different versions of the same software, and that's currently going on right now. So we want to control the software being used very tightly. In fact, we just got rid of JSON, and we're just using JSON now. So it's very tightly controlled, and we're moving all the software forward to newer tools. So it's developed like it has a Java, and then this is also the same way that it's being done at Google as well. So they have a third party. They don't have a Google branch. They just have a third party branch Java, and then they list all the different packages, and they put the version of the package that's there, and they're very tightly controlled at Google too with a single version. I think as you're developing and if you're testing, you'll have a second version there, but the code points to a single version inside there. And then we also have Gradle and Groovy in the tools section. So the Storm Central just has libs.gradle and then third-party Google and tools. That's it. So it's only the repo for external packages. And the libs.gradle looks like this, where you can point to the Google. So I actually point to the Google tree, and I point to the third-party tree, and I have this pattern down. And I define external libs, and we just go through there. And you put like Guava, and then you put down this version 16 and JSR, and it points to this special third-party there. So in this one file, we define all the shortcut names used inside the build file. So if you come over here to this build file, you just use Guava. You just bring in Guava. So we have short names for every single third-party package out there. Commons IO, Commons Lang, Guava, GAE support. You know, we have short names for everything. All the packages use short names, and they're all resolved through this libs.gradle, which defines everything. So I also put libs.gradle on the Storm Central side, so when I update Storm Central, it would be self-contained, and you don't have to worry about updating both repositories. So the Gradle scripts just refer to libs.gradle on Storm Central side. So as they update versions, after versions there, it's all self-contained sources. In Storm Central, that's why it's independent. And that's my talk. And if I ask questions, ask what you want to look at and stuff. No, probably not. I did not want to. I actually wanted to control it myself, and the Maven stuff's controlled by other people in the company, and I want to just download and move fast and pop things in. And I didn't want to use Maven Central because I couldn't control. So the question was, why did I choose to use Git and not a Maven repository for Storm Central? Hope I got it right. And so I just thought that I could control it better. I thought I could just pop it on an external drive anyways and just have symbolic links for everybody. It would be very, very fast and straightforward. And I didn't want Storms. I did not want to use Maven Central because it's very hard to control what people do in the build files. They can just start bringing things in directly without even setting it up in the libs. So I've been avoiding to pull in Maven Central. I would have done it a few times because some packages are really hard to scope out with all the palms and stuff. But the problem is there's no way of bringing in for one package. If you have the word Maven Central, you're doomed. You can't shut it off for anything. So I've been trying to avoid that totally. But it does make things a little harder. But there's only me doing this, so there's other people who are all benefiting from it. I'm also going around and refactoring their code and building up. So they've never gone through reviews before. So it's like when I'm migrating projects into Storm, it's like their very first review. So it's painful. Any other questions? Do you want to see any of the code, or you want to see how the slurper looks? Or yes. So now it's not an issue, and I don't think it's going to be an issue because we can write test suites, so you're only building the package you're really using. You don't, even though it's big, you don't need to build the whole thing. So each person can build their own test script that says, I want to build these things, which goes ahead and builds the corresponding. So if your tests are complete, when we get to that level that the tests are really complete, every file's got a JUnit test on it. Therefore, when you build your test suite, it points to, oh, your source code, and everything gets compiled. And if you don't have enough tests, it's a different issue. But we're trying to build up the test suites. In fact, at Google, they use, for you to construct a project, you just point to your, oh, I forgot what the main thing was. At Google, they, if you want to have a project brought into the IDE, you just point to your test suite. It will go and suck in everything that you're using. I'm not that far advanced with Storm. I am thinking of open sourcing this project if other people also are interested in this kind of development using Gradle. And I think I'll be taking some steps in the next month or two to start open sourcing it. Yes?
The config slurper thing you mentioned, I don't know if you can show.
So he's asking, see, I'm going to get you. So he's asking to see the conflict slurper. So that's in the build.gradle. Let me, I'm in the groovy one, sorry. Clicked the wrong one. Groovy was open. I think that's awfully small. So here I actually process all the build files. Just trying to find it. I don't go in here very often. So we run through the whole thing with these build files, and we're looking for the build files here. And we run one time with source, another time with tests here. So here it looks for cache the build file. So we're actually going through and we're pulling all the build files in, so we get all the directories. The tests.
So that's by convention, people need to put the right file in the right places.
You had to have build files, yeah. You had to put the build. So if you want to open up a new package, you just go there, copy some build file, and drop it in. You're done. It takes like 2 minutes to do a new package, and you don't have to worry about wiring it or anything. You just start pointing to your dependencies, and you're off and running. So it's really lightweight. Makes people. I like that feature because you want to have other people not be afraid to refactor correctly. If they have to spend 15 minutes setting up a Maven directory and all that stuff, they might skip it. So I actually go through here, bring the build files in here, and I'll show you that code, and which caches the build files, and then I call each one of these build systems. So I have Java build, jar, war. There's a war to jar somebody asked for, and a test suite. And the slurper itself is here. Sorry it's all red. It's an IDE issue. I had it black at one time. So I actually I'm actually returning these config objects here. So I'm going through the build file, creating so I have a map of the rule, which is a Java build or the Java test, a test suite or a Java jar. That's the rule. I come up with the name of this dependency, so it's a name in the Java jar file for that rule. So so every rule has a name first. So that name is the dependency name here. And then the spec is the entire object, which can then further parse later. And it just walks through the slurper, builds them up when you point to them. And that's basically it. It's pretty straightforward at that point. I had to put things on dependency map and a few things. I'd have to look at this code because I haven't looked at it for quite a while. I had to do some name flipping around for the map and stuff. But basically this builds the objects and it returns back, and then each of the objects itself, I can show you how one of them processes that. No. So like the Java jar file here would get all the config objects from there. You'll see the config objects coming in over here. And then we start processing, and we get deeper and deeper into the config object as we start processing it. So this works a little bit heavy, but it's done once, and you can reuse it. You don't have to get into this stuff. You just need to create build files and point to your directory. So if this is open source, I was hoping somebody else would help manage some of this and build it up. That'd be the purpose of open sourcing it. But it does work now. I can create WAR files and jar files, and we'll probably be adding a few more for deployment. So we do automatic deployment, or we'll add some tasks for deployment. Right now they have to expand the WAR and then execute one command, so it's not a big deal. So with 2 commands they can deploy. Yes?
Can I go back to the slide, and first you have a directory structure. I was wondering, so everything is one Git repo, including the source code and the libraries? Is everything in one Git repo?
So I have two Git repos. So this is one of them, which is all the source and the Gradle scripts that we wrote. So if it was generated as our source, it's in Storm. If it's external packages, it's in Storm Central. The only difference is libs.gradle sits in Storm Central, so it's Storm Central is self-contained. So this is one of the trees, and the other tree is this tree for Storm Central.
So I was just curious, how do you get for example, jar from the Storm Central? It doesn't require every developer has this repo locally?
Yeah, right now. So everybody, the question was, do you have to keep the repo on your machine pretty much? And the question is yes. I am hoping to persuade the powers to be to get me a network drive so we can do symbolic links to it. So, because to me it's silly to have everybody have the entire repo, but it's development. People work at home. You just download the jars and you got everything you need. And I don't think disk space is any problem anymore. So this diagram kind of shows the overall picture where there's one Git repo is Storm Central, the other repo Motorola one. If I go back to libs.gradle, I can give you a picture of really what it looks like. So as you can see, there aren't that many jars inside third party right now. It's not like a big deal. It might grow when we get more and more projects going. We are working on in the Google Cloud, so we're using Google Cloud for most of the heavy work. And this is libs.gradle. And I actually grouped some files together so people don't need to list every single jar they need. The cost is pretty small. So there's a GA import. So if you're implementing GA, you get these import jars. We have a shared one. We have Guava and Groovy and JSON and Hadoop and other packages. They're all just brought in this way. And all you need to do in your build files is say JSR 305. And if we get a new version, you don't need to update all the build files.
But that doesn't handle the transit dependencies or manage all the transit dependencies using the same widget?
I haven't run into too many problems so far. We have had to bring in a few extra jars and a couple of projects when they build the war files weren't complete. But
As long as they are self-contained.
yeah. So I handle the dependency tree on the build side. We don't handle it on the jar side. We don't have palms and stuff.
So if you're developing against a newer version for compatibility tests or for whatever reason, a new feature that's coming, you know, check this file out and keep that file. I mean, how do you like sort of override it so you can locally test with something different?
Well, you could add your own version. Yeah, I mean, you can just modify this file and not check it in yet if you're testing. At Google, so the question was, sorry, the question was, if you're doing modifications and you want to try a new feature, what do you have to do? So it's important. I feel it's very important that everybody's on the same version because as you're developing going forward, projects lag and it's very hard to get them caught up. At Google, they also keep the same version, so I was trying to mimic that behavior here as well. And if you want to move forward, you would make your own version here first and you would run the tests. Hopefully when the tests are really sufficient, they are at Google, they're not here, they aren't at Motorola yet. But when you run your tests against a new version, you might have to go through and migrate some code to go forward. But that's the cost of keeping everything current. If you fall way back behind and move everything at one time, you're in a total mess. So there's a cost, there's a constant cost keeping things current, or you get out of sync and then you have other problems. So it's your choice.
But I mean, how would you, so if your testing goes fine, and now you develop your feature against this
Mm-hmm.
new version that you pulled in, you need to deliver it. So you make a,
So I would just update the jars and update the version and switch this to point to a new version.
so, but anybody else who's depending on JSR 305 is now going to get a newer version.
That's right.
And maybe not have tested with it.
Well, there are complete tests. So if you run, I mean, it's a problem now at Motorola. I'm not going to say we have complete tests, but if you when you build your complete test suite out, the complete test will catch those issues easily. And you warn people up front that you're moving versions, and you might ask some people to help you with it. And it is painful, but there's a lot less pains associated with everybody being on the same version than having 15 versions of software in there. When I first got there, I would load their repos, and I had to they'd have 3 or 4 versions of the same software there. I had to guess which version they were using. back and forth to get the right API. I mean, it was horrible. And then every project had different versions around. And if you're doing code search, you know, you're going to get 3 or 4 different versions. You don't know which version you're pointing to. You don't know what you're running on. So it's worth the pain to move everybody forward. Even some dead projects, it's okay. I mean, if they're completely dead, you can mark them dead and not build them or stuff. But I have moved the projects forward, and we haven't run across any problems so far. We do have to worry about migration with Objective 5 going to 5, so we're delaying that. And then I also have the test libraries are down here and checks out some other things. So that's the complete libs.gradle. Every time we add stuff or remove jar files, this is updated. And it's with the Storm Central code. Any more? All righty. Thank you all.